All right. Good evening, everyone. So, in today's session, we are going to, I am going to guide you through one of my computer vision project, the kidney stone detection. So, let's get started. So, first of all, for any computer vision project, we need a clean data set with some some certain amount of images, right? Some inputs. So this would be our inputs for this project would be the images containing or may or may not containing the kidney stone images present in some of this. I don't know whether it is an MRI scan or a CT scan. What is it? But as you can see, the link of this dataset I will provide you in the description so you can access it. So, as you can see, this dataset contains 1300 images, which has something like this. Originally, this image looks like this, and the white part, as you can see, contains the stones. Right? If I like hide the rest of the things and show the annotations, you can see here are the kidney stones. So, in order to access this dataset, you have to go into the Roboflow, and let me show you actually the Roboflow universe. These this website particularly contains a repository, you can say, of models as well as dataset for computer vision. So from here you have to go into the universe which is being opened here. Now you have to search for, suppose if you are working on kidney stone, so you have to search for this and you might get some similar results. Okay, but since we are working for the on this dataset, I'm going to walk you through how to import this dataset into code. Right, so since this dataset has already been created and annotated, we do not need to annotate these images. Otherwise, if you are working on a custom dataset which is not present on this website, all you have to do is to collect the images and then annotate them. So for that part, I will discuss in another session. So for this session, I would walk you through how the dataset has been splitted across train, test, and validation. So, as you can see, 2730 images are present in train, 260 on valid, and yeah. So for pre-processing, they have applied auto orientation and resize to 640 cross 640. The augmentation they have used is crop, all these stuff you can see here. Now, in order to import this dataset into the code, all you have to do is to click on download dataset, select this one, download dataset, and continue. Here you can see you can select the format. So if you are working on YOLO V8, there are so many formats available in this website. So it is completely based on your requirement. Whether like it depends which model you are using. So if you are using YOLO V4, V6, V5, you can select those. So for now, we are working on YOLO V8. So we'll select this one, and we will click on show download code. So it will create an API link which will import this dataset into our collab notebook or whichever environment you are working on. So let's click on continue, and here you can see you have got the API from which you can download this dataset. Correct. Now I will switch the tab to show you the code. So, oops, here's the project. So you can copy paste this API link here, right? Since I've already downloaded it, so uh, it 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 won't matter, right? Because I've already downloaded it. If I connect to a runtime, it will automatically show up here. So yeah, let me remove it, and then all you have to do is to run this cell in order to download your dataset. Then moving on, we have to, in order to work on a computer vision project, especially YOLO, on a yeah, so on a YOLO model, you have to like install this Ultralytics library, and yeah, then you can import the YOLO module from Ultralytics, and you can select whichever model you have to work, whether it may be nano, small, large, or XL, extra large, whatever. So I have chosen the YOLO V8X, the extra large model, and I have defined the model architecture like the YML5. So so if you download the dataset, like if you run the API link, which I have pasted here, you will get a folder like this in your runtime. In this folder, you will get something like these files as format: the data YML, test, train, and valid. So just a second, someone is at my door. So yeah, so if you run the above API link, you will get this folder, and in this folder there are the test, valid, and train modules, which contains the images as well as the annotations. So the main concern is here the data.yml file. You need to provide the folder paths to the images. Like you have to change these. All right, you have to change these paths with these. So since this is test folder, I would give it like this. For train, I will change it to train, and for the valid, I will change it to valid. Now all good. Make sure to save this changes, save the changes, and yeah, that's it. Run this block of code to train your model, and after some time, about an half an hour, you will, depending on your machine type, the training will be completed. So after the training has been completed, you will have your best.pt file, the weights file, somewhere around here. The runs folder will be created, and in this runs folder there will be the detect, and in the detect you will have weights, and here's the weight file. So all you have to do is to provide the path of the weights file here and load the test images. So all I'm doing here is to run the model on the test images and getting the prediction results. So the prediction results are being saved in this predict folder. So in this predict folder, I'm having the predictions of the model, which is being able to detect the kidney stones. So as you can see, these are the prediction results. Right. Okay. So let me close it. Hmm. After getting the prediction results, we can download the folder, the runs folder. We can also see the results. using the gblob, which is a OS library. So here are the results. And yeah, you can also have a look to the confusion matrix, how your model has performed on validation set, the F1 curve, the results file. You can have a look how the train loss has been reduced from the very start. This all these graphs indicates or demonstrates how your model has performed across the number of epochs that you have set. As you can see from from the very first epoch, the train loss has decreased drastically. Same with the class loss. Yeah, if had I run for more than 100 epochs, it might have reduced more, but I don't think so. I need to. My main goal is to make a working model right now, not to create any like what can I say? Forget about it. Here's the PR curve, and yeah, that's all. That's all for the project. So I'll be providing this notebook link as well as the dataset link in the description. So make sure to download it. And yeah, thank you.